Hello friends, this video on equilibrium part 36 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched all the previous parts. We have to calculate a degree of ionization of 0.05 m acetic acid if the Kp value is given, and how is the degree of ionization and dissociation affected when the solution also contains 0.01 m HCl. See, calculating the degree of dissociation is very simple. See, pK is given, that is 4.74. With that you can find K, that is minus 10 antilog of this, you get 1.8 to 10 to the power minus 5, right? And with this, you know that degree of dissociation is nothing but alpha is nothing but root K by C. K is we have got 1.82 to 10 to the power minus 5, and C is we have C 0.05. You solve this, you get alpha as 1.9 10 to the power minus 2. So this is easy, right? Degree of ionization. Now the question is, how is the degree of dissociation impacted when we have HCl? So I have HCl, if you see, it will completely dissociate into H plus and Cl minus ion. Correct. So the reaction I had was acetic acid reaction, CH3 COOH gives CH3 CO minus plus H plus. So let's assume this already had T is equal to 0, had 0.01 MHCl, right? This was 0, and CH3COH also we had 0.05 M acetic acid. Let's assume at T is equal to equilibrium. So this assume that this moves in the forward direction. Let's assume, right? So in that case, this becomes X, this becomes X, and this becomes X plus 0.01. Correct. So if you see the concentration of CH3COH, and it will move very less actually. It will move very less. And since we need to find the degree of dissociation, so let's not take X here. Let's take into 1 minus alpha, right? Because alpha is the degree of dissociation. And this becomes C alpha, that is 0.05 into alpha. And this becomes 0.01 plus 0.05 alpha. Correct? Instead of X, I am taking C alpha now. So if you see, since the reaction will proceed very less in the forward direction, I can assume that concentration of CH3COH is almost equal to 0.05. So alpha is almost 0. And CH3CO minus I can't ignore here, so it has to be 0.05 alpha. And H plus I can take it almost equal to 0.01 because this is very small value. Right? So if I had the formula now K, this will become concentration of H plus CH3CO minus by concentration of CH3COH. Right? So that is nothing but H plus is what? This guy 0.01 into CH3CO minus is what? 0.05 alpha by CH3COH is 0.05. It's cancelled. And this is equal to what? Given we have got this guy. K 1.82 10 to the power minus 5. You solve this, you get alpha as nothing but 1.8 into 10 to the power minus 5. Very small value. And that is right. So what we have done, when we started at that time only we had some hydrogen ion concentration from HCl. That is the only thing here. This is a similar question what we had in the last one. So the ionization constant is given. We have to find the degree of ionization. So degree of ionization is nothing but root of Kb by C. Nothing but 5.4 10 to the power minus 4 by C is 0.02. You solve this, you get 0.16. This is my degree of ionization. The next question is, what is the percentage of D-methylene is ionized? The solution already has 0.1 MOH. So this is also very easy actually. If you see, I'll just do a little bit CH3, C2, NH plus H2 gives CH3, 2, NH2, NH2 plus OH minus, right? So at T is equal to 0, it says that it has 0.1 m NOH. So 0.1 m is there. This is not there, this is ignored, and this is, we have 0.02 m, right? So at T is equal to equilibrium, so this will have, let's suppose, 0.02 minus x, this will become x, and this will become 0.1 plus x. Correct. So my kV is what? Same thing. This guy 5.4 10 to the power minus 4. This is equal to what? Concentration of this is x, concentration of this OH minus, that is 0.1 plus x, almost equal to 0.1, and this 0.02 minus x, almost equal to 0.02. So you solve this, you get x is equal to, you'll get something, but I want alpha. Alpha is what? Cx. I want alpha actually. So if you see, C alpha is equal to x actually. So alpha is equal to, C alpha is equal to x. So alpha is equal to x by C, right? Let me try to find x by C, this quantity. So this becomes alpha. So I get from this, alpha is, if you want to find 5.4 into the power minus 4 divided by 0.1, that is 5.4 into 10 to the power minus 3. This is my new alpha, right? So this is easy actually. And if you want to find percentage dissociation, this is what? Nothing but alpha into 100. So 5.4 10 to the power minus 3 into 100, nothing but 0.54%, and that is my answer. A very similar question. So the question says the pH of milk, black coffee, tomato juice, lemon juice, X are these is this. We have to find the corresponding hydrogen ion concentration in each one. Pretty simple. See, H plus is nothing but pH is nothing but minus log of H plus. So H plus will be what? H plus is nothing but, if you take negative both sides, so minus pH is nothing but log of this. So H plus is nothing but log of anti-log of minus pH. So you find the anti-log of minus 6.8, you will get value as 1.585 10 to the power minus. This is done for milk. Similarly for black coffee, 5. So this H plus ion will be anti-log of minus 5. That is nothing but 10 to the power minus 5. Done. For tomato juice, H plus will be what? Anti-log of minus 4.2. Nothing but 6.31 10 to the power minus 5. Similarly, lemon juice, H plus will be what? Anti-log of minus 2.2. That is nothing but anti-log of minus 2.2 is 6.31 10 to the power minus 3. And then I have egg. So egg will be what? Anti-log of minus 7.8. That is nothing but 1.585. This is pure maths where you define anti-log of minus pH, right? So H plus ion is nothing but anti-log of minus pH. That is my answer. So the question says 0.561 gram of potassium hydroxide is dissolved in water to give 200 ml of solution as 298 Kelvin. We define the concentration of potassium hydrogen hydroxyl ion. So everything we deal in moles per liter, right? So let's find the molarity of KOH. That becomes 0.561 grams, right? And and what is the molar mass? 56 into per liter. So I have 200 ml by 1000. This is my per liter. So if you solve this, this comes out to be 0.05 m. So I have 0.05 m of KOH, gives K plus and OH minus. Since I'm drawing single side, because that means there's a very strong base, it will dissociate completely. So this is 0.05 m at T is equal to 0. T is equal to, after some time, this becomes 0, this becomes 0.05, this becomes 0.05. Right? So my OH ion concentration is nothing but 0.05. Correct? Similarly, my H plus ion concentration will be what? 10 to the power minus 14 by OH minus concentration. 10 to the power minus 14 by 0.05. That is nothing but 20 to the power minus 30. If you want to find the pH, nothing but minus log of H plus ion concentration. That is nothing but minus log of 20 into 10 to the power minus 30. You solve this, you get pH as 12.7. That's the answer. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.